Hello students, so now this is the second video of day one, and we're going to talk about what a limit is. A limit is a mathematical way of describing what a function is doing, the function value is doing as the function's input value is approaching its own value. So let me explain with a picture. So a lot of times in pre-calculus, we're going to discuss what a function value is. So what we do is we may say, like with this graph here, we may say, what is f at 0? And that's describing a function value, because when you go to x equals 0, you look and see where it maps to. It maps to a y value of 1. So that's finding a function value. But a limit is something different. A limit says, and it may sound like it's similar, but a limit is very different in terms of if I asked you the same question and I said, what is the function value at 1? If you looked at this graph and you went to 1, you would have to say that it does not exist. But a limit allows you to discuss, if I say a limit, LIM is the abbreviation, and I say as x approaches 1, what is f of x going to equal? Now this is like studying what the sides of the function are doing. So as x approaches 1, I'm going to head towards 1 from the left, I'm going to head towards 1 from the right, and I'm going to look and see what my function value is heading to. And as I go on, as I ride on the function from the left, heading towards x equals 1, my function value is heading towards 2. And if I look at it coming in from the right, it's heading to the same value. So the limit tells you, it gives you a description of where the function value is heading. So in this case, it's heading to the value of 2. Now the function does not equal, f at 1 does not equal 2. The limit says that the function is heading there, but in this case, for this graph, it will never have that value. It's just going to head to that value. And the next problem here, if I asked you, hey, what's f at 1? You would simply say, oh, it equals 1, because a function has a value there. But if I asked you what's the limit as x goes to 1 of the function, you would have to say it's heading to a value of 2, because it's heading to the value of 2 from both sides. In this case, if I said, what's the function value at 1 again, you would say, well, it equals 2. And the limit as x approaches 1 from both sides is like it was before, headed at 2 from both sides. So hopefully this gives you an idea of how you look at limits graphically, and that's what a lot of our work in class is going to be. And we have another example too. We have this function called, it's an important function to kind of remember. We have the limit as x approaches 0 of the sine of x over x. Now this is a tough function to understand, but it's a good one to look at graphically. So what I'm going to do is I've already put it up on Desmos, and so what we're going to do is we're going to look at as x heads to 0 from both the left and the right, and we're going to see what the value goes to. So here's a function of Desmos. You can see I've put it into the equation, and I'm going to just probe a point. Now as I go from the left, the x value is at -1, and I'm going to drive the x value to 0 as I move in from the left. But what value is the function heading towards? It looks like it's heading to a 1 value. And if I do the same thing on the right, see how the cursor is moving and I'm heading to 0 from the right, that means that see the x value is heading down to 0, and as it gets to 0, what's the y value heading to? Well, it says undefined, but it's heading to a value of 1. So here you could say, back in our notes, that from looking at the graph, as x goes to 0, of the crazy function sine of x over x, that is equal to a 1 value. I hope this video has helped explain some of the things that deal with limits and reading limits graphically. But in class, we're going to be working on more problems with this. So this is just like an introduction, and in class, we should be doing a lot more problems. So I look forward to hearing your comments.